You're listening to HVAC 360, live from the AHR Expo 2020 in Orlando. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. I do that either by sharing information, specific lessons learned from the field, or talking with industry experts. At this point in time, again, I usually encourage you to go over to the newsletter, and you still can, HVAC360.com, and sign up. But I really want you to go over to YouTube, search up HVAC 360, click on my channel, and subscribe. I'm trying to get my first 100 subscribers, and I really want you to be a part of that. So, what's up for this week? This week, I'm going to be talking with Dan Jones, who's the president over at UV Resources. I had a great interview again with Dan, and there are still some nuggets of information. So stick around with my post-interview debrief, and I'm going to share some more information that I obtained. So a lot of, and the reason that this is happening is that, I go and I interview these people, and then we stop the interview and we keep talking, and there are just some more things that I think that you really should know. I really want to share with you, and I think that's important. So stick around after the interview to hear what I have to say. All right, well, enough of that. Let's just cut to the tape. All right, we're on the floor of the AHR Expo here in Orlando, Florida, 2020. We're here at UV Resources. I'm talking with Dan Jones, who's the president of UV Resources. How are you doing today, Dan?
I'm doing great, Matt. Thank you.
So, can you explain a little bit about the company and what you have new for the show?
Sure. We've been in business for 15 years, and we came out of other UV companies, and our primary market is the commercial industrial market, where we're applying UVC to HVAC systems downstream of the cooling coil.
So now, what is, as far as the engineer would be concerned, what is the right application for these type of products?
Well, basically, when we're talking about downstream of the cooling coil, purpose of putting it there is to irradiate those coils and keep them clean. On a new construction, when you have a new coil, it's going to keep those coils clean forever, basically, as long as you maintain the system. But going into a retrofit situation where you have a compromised coil, maybe your pressure drop has gone up beyond what it was specified for, leaving air, wet bulb temperature has started to climb. UV is a great application where you put it downstream, it goes in and starts eating up the microbes and bacteria, biofilm that's gotten on that coil, and improves that heat transfer ability of the coil, reduces the pressure drop, and in turn your wet bulb temperature starts to go back down.
Now, who do you see adopting this, currently?
Well, forever, healthcare markets have been the place. I mean, basically, they're concerned about biologicals in their air handlers. They are the early adopters of it. But more recently, we're seeing more and more commercial buildings incorporate UV for many of the same reasons that hospitals do. Of course, they're worried about infection control. But, buildings are worried about better indoor air quality, but also efficient equipment, saving energy. HVAC is one of the most expensive parts of their building as far as energy use, and if they can have an efficient one, it's definitely something they like to take advantage of.
Now, if I'm a consulting engineer looking at adding UV to my air handling units, what are some of the particulars that I need to know in, specifying it?
Yeah, so basically, we've been out there doing ASHRAE talks and doing engineering presentations, and what we find is that sometimes there's a misconception about what UV is for, because early on, UV was for indoor quality. That's what they went out there for. And so that's kind of the perception from engineers is, this is just for indoor air quality. So when we're talking about energy efficiency, it's an eye-opener for them about what it's about. So when they're looking at a system and trying to understand how much UV is enough UV, ASHRAE has done a lot of work in their HVAC application handbooks. talking about UV. There's chapters on UV in both handbook, or in 2 handbooks rather. And basically what we're talking about is how much UV is enough. It boils down to about 7 watts of UV is good, so per square foot of coil, excuse me. So every lamp is stamped. You go to Home Depot and you look at the lamps, they have a wattage stamped on them, maybe a 60 watt lamp, fluorescent lamp. Same thing with UV, they have wattage stamped on them. So basically once you figure out your square foot of coil, you take out all the lamps that you have in there, take the wattage, combine them, divide them by the square feet, and if you're at 7 watts per square foot of coil, you're in great shape. Anything 7 and north of that.
Fantastic. Now, I guess how does it come into the field? I mean, as far as installation goes, I mean, is that something that's easy to do, or how is that done?
Yeah, so we do a lot of work with OEMs. So a lot of times air handlers come in new with UV, but on a retrofit, we've done a lot in the last few years to basically create a kit for the installer. So everything comes in one piece. You've got your vertical supports to hold the lamps, you've got your power supply enclosure, your lamps, everything comes in one kit. So when the guy gets out to the field, he can either size it up prior to going there and cut his vertical supports at his shop and then install it, or it's very easy to do in the field. Just the goal is to make it very easy, and it's pretty straightforward.
Now, what are some of the safeties that come along with UV systems?
Yeah, so you don't want to be exposed to UVC. So everything that we put out there, we have safety switches, door safety switches. We introduced last year the ability to control up to 6 doors with one controller, and that's 12 volt. So low voltage, easy to control, mini doors, because you do not want anybody walking in, opening a door, and being exposed to the UVC energy. It'll actually burn your skin, it'll burn your eyes, but it doesn't penetrate deep in, but regardless, it can be pretty painful.
So I guess you can liken it to welding. If anybody doesn't wear a long sleeve shirt, welding, they're going to end up with burns on their arms and burns on their hands.
Absolutely. And in a sense, it's actually not as bad as welding, because UV doesn't have real good penetrating power. So it kind of works the surface and just kind of etches away at it. So if you're exposed to UV, for example, in your eyes, that kind of top layer is going to be exposed to it. It's going to be painful. Once that sheds, then you're good. So it doesn't have that deep penetrating power that you might get from like a welder's arc.
Now, as far as electrical connections, what sort of electrical connections can you use with the UV?
Well, from an electrical standpoint, it's 120 to 277 universal input into the power supply. So that's basically, you can take any of that. Typically, you'll see that in the lighting circuits can handle UV. It's not a big draw of electricity. It's a fluorescent tube. So if you look over your workbench at home, you have a fluorescent tube over it. Same concept.
Great. Now, I guess what other things do you have going on at the show besides the UV lamp?
We have a different application, which we call the upper air application, and in this application, you're killing mold, or actually pathogens in a room. So you're mounting a fixture on a wall. It's creating a kill zone in the upper room. And so we've had this product out for a number of years. We just came out with a smaller one, because what we're finding is in patient exam rooms, our larger one is too big. It's putting too much UV in there. So we have a smaller one to take care of those exam rooms, because those are the places where people don't know. People who are doctors and nurses who are talking to patients, sometimes they don't even know what the patient has. So having the ability to have a UV system in the room to kill anything that patient might have or be communicating to them is really important.
Now, is something that is, how is that controlled?
It's actually on 24/7. It's mounted on the wall. It has to be 7 feet or above, and it just runs, and you get this kill zone in the upper air. We're all talking about now coronavirus and looking at coronavirus and what's going on. So we've actually got questions from different airports because they want to quarantine people. And so when the system's installed, and a person comes in there infected or potentially infected, the natural convection in the room will actually take those pathogens up into that kill zone and kill them. So it's a mitigation situation.
All right, fantastic. Now, are there any applications where this is kind of misapplied or engineers shouldn't think about using it?
Pretty much if there's an HVAC application, you could use UV. It just comes down to what you're trying to accomplish. So if it's surface irradiation like we talked about for coils, there's virtually no coil that would not benefit from having UV on it. The other application we talked about was on the fly, where you're trying to kill something in a moving airstream. And just kind of understanding that you have to separate those two applications. And so from an engineering standpoint, you might be thinking, well, I want to do both. Well, of course, UV works on a time and intensity basis. So you need time and intensity to kill something in a moving airstream. When we're irradiating a coil, we're on 24/7, 365. The coil's not going anywhere. So we have a lot of time, so we don't need a lot of intensity. But if you're doing it an on-the-fly application, where you're trying to kill something moving by it, you don't have a lot of time, so you need a lot of intensity. So just kind of from an engineering standpoint, understanding the concept of what I'm trying to accomplish, and then applying the correct amount of UV for that.
Right. And if they have any other questions, obviously they can reach out to UV Resources and ask them directly, right?
Absolutely. We do that. We go out, we do presentations, lunch and learns all the time for that.
All right, thanks. Anything else, Dan, that we have to talk about?
No, Matt, I appreciate you taking the time. We do have a sizing app out there on either the iPhone or Android. It's called UV Select. It's UV and there's a space Select. You can actually go into that, size up any system, gives you kind of a ballpark number where you can start with, so you understand the cost of UV in a system.
All right, appreciate it. Thanks for the time, Dan.
All right, thanks, Matt.
All right. Thanks again to Dan Jones for taking the time to talk with me. Check out the show notes for links and things that we mentioned during the interview and some other things. You can go over and find those show notes over at hvac360.com/151. Now for a little bit of the debrief. One of the things that I asked was, how often do you actually end up changing the tubes? And he had stated that you want to be able to replace the tubes for the UV filters. You want to be able to replace those annually, just like a light bulb. A lot of people who you may or may not know, but a light bulb obviously is going to be the brightest when it's bought, and over the period of its life, it's going to degrade slowly over time. A lot of light bulbs, a lot of lamps. I don't know. I'm not an electrician. I'm not an electrical engineer. They call these. So a lot of the lamps, I think, end up degrading over time. It's not that a lot of them fail. It's that they get they just continue to get dim and degrade over time. And when it hits the, I think that it's referred to as an L85, when it's 85% of its original brightness over its lifetime, that's usually the indication of where it needs to get replaced. So that's typically what it's going to be for these UV bulbs. It's not that they break or they go bad. It's just that, as with any light bulb or lamp, they have a certain degradation. All right. Other than that, they really don't have any maintenance. I mean, if you're cleaning them if you're replacing them once a year, they really don't get that dirty. Now, I was talking about, really, does it really penetrate the coil? I mean, if you have it downstream of the coil, kind of shining back up, does it really get that far? And, he mentioned something, kind of counterintuitive or just really intuitive to me, that these are aluminum fins on the coils, and so that really does allow the UV light to kind of bounce up and down, back and into the coil. So it really does allow that to get all the way in there. Not even when you talk about pressure washing the coils. When you talk about cleaning the coils, they don't even really get that. There's only a certain distance that penetration actually occurs. So they said that the UV penetration is really all the way through the coil. Another interesting thing is it's like one of those things. It's like, what happens to the dirt? Because if you talk about the biologicals being attached to the coil surface, does it get just re-entrained into the air? Does it kind of blow off, so to speak? And what he said was rather interesting. He said, no, because of the condensation that's occurring on the coil, it actually, as it degrades and falls off, all that dirt and debris kind of goes into the condensate. So it just follows the condensate all the way down into the pan and washes out that way. So those are some of the nuggets that I found out after we turned off the mics, and I just wanted to share that with you. So that's it for this week. Thanks so much for listening. I hope it was helpful. If you know anybody who's looking to step up their HVAC game, consider sharing this episode with them or one of your favorites. Either way, this is by far the best thing that you can do to spread the word about the podcast, and I really do appreciate it. If you want some extra credit, I will say again, go to YouTube and subscribe. The next thing you can do is subscribe to the newsletter at HVAC360.com. And the last thing you can do, again, greatly honored if you'd consider leaving me a 5-star rating and review to Apple Podcasts. This really is kind of a way that to show other people looking for valuable information about HVAC in the commercial environment. It's a signal to them that says, hey, this is something worth listening to. So I really appreciate that if you would do that for me. All right. Well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.